Okay, so yeah, good afternoon to all of you. Um, so I hope so far all of you have enjoyed the course. Let me just do one thing. Maybe in the YouTube, let me. Okay, so just a minute. I have to all of you. So I hope so far all of you have enjoyed the course. Let me just do one thing. Maybe in the YouTube, let me. Okay, so just a minute. I have to all of you. So I hope so far all of you have enjoyed the course. Let me just do one thing. Maybe in the YouTube, let me. Okay, so just a minute. I have to all of you. So I hope. Okay. Sorry. Yes. Uh, so let us first look at the lectures, whatever we have done. Maybe if I understand now, all of you are in module 3. If some of you can speak up, it will be helpful. So you are currently doing module 3, right? I'm asking the participant. Uh,
Yes, sir.
Right. So in the first two module, let me in the first module, we have covered 3 lectures. Then we had a problem solving session. First module was meant to familiarize with you the necessary mathematical tools and some relevant concept that we needed to understand quantum entanglement. In the second module, we discussed about some introduction, basically some technical introduction to quantum entanglement was given, where we also discussed Smith decomposition, EPR paradox, and Bell's inequalities, followed by a problem solving session. And in module 3, we discussed quantum measurement, uh, lecture 7, then lecture 8, properties of quantum entanglement, then problem solving session 3, and in lecture 9 we are discussing quantum entanglement measures. Now you are going to get about in module 4, you are going to learn about quantum measurements, of course in the context of discrete variable. And here in lecture 10 and lecture 11 first part, I have discussed about quantum entanglement measure in the context of continuous variable entanglement also, but very briefly. Then lecture 11 and 12, I'm giving you some example on applications of quantum entanglement. So it is a two-part lecture. Then finally it will be followed by a problem solving session. Now you see, attending and going through the problem solving session, all the problem solving session is very important, because sometimes certain concept, if I am not able to clear in the lecture class, then I am trying to make it, understandable via problem solving session. And there is going to be another 2 lectures you will get in under module 4. These are additional lectures, and they are not going to be part of the examination. One is this lecture number 13 and lecture number 14. This is on continuous variable quantum entanglement. And you see, personally, I think that these 2 lectures, while they are additional lecture, they are of immense importance for anyone who wants to start doing research in the area of quantum entanglement. There are certain materials that is covered in a very, very simplified way, which you will not get in any literature or in any book. They are there, but they are written in a very difficult language, and it's very difficult to decode them. And I have simplified it for you, and then it's my belief that you will be able to understand research literature after going through lecture 13 and 14. And of course, to understand lecture 13 and 14, you have to go through the earlier lectures from module 1 onwards to module 4. I'm particularly very happy about the last two lectures because that was one of my uh, intention for offering this course, so that whoever the audience, the viewers can at least understand some modern literature or whatever is going on currently in this area of research. Now, let me now answer some of the queries and comments from the participant of the course, which I have got from a doc file. Some of you have asked question. For example, three persons question I got. The first was these two questions were asked by Bhagyesh. He asked why quantum gates have to be unitary. Gates appear as some external operation on qubits which otherwise evolve according to the Hamiltonian. And his second question was, what does the measurement operator measure? Does it correspond to any physical observable? I hope all of you are able to see my screen, right?
Yes, sir.
Okay. So let me answer Bhagyesh's question here. First of all, you see, I'm just quickly trying to remind you about quantum gates because his first question was related to quantum gates. You see, the idea is that qubits, store information, and if you really want to manipulate qubits, then you have to make some operations on the qubit, and these operations are done through something called quantum gates. Basically, you make measurement or something like that. You make observations, and in quantum mechanics language, what you basically is doing is that qubit is a quantum state. You are mathematically speaking, you are operating on a quantum state, and an operator has to be, if it is, it has to make sense, then this operator has to be Hermitian. So quantum gates are also basically, Hermitian operators only, and they have to be unitary because of the reason that when such operations are made, the norm of the state has to be preserved, right? I think this is the reason. In fact, I have written it here. When measurements are not made, you are correct that the state is basically going to evolve as per the Schrodinger equation or as per the Hamilton's equation, basically, which is the Schrodinger equation, and the system has to preserve the norm during the time evolution. That's why all these operations has to be unitary, because unity always preserve the norm, or basically the probability. Preserving unitary means conservation of the probability. That way you can think of. And his next question was related to measurement operators. Now, measurement operators I have discussed in great details, but again, just to remind you about that measurement in classical mechanics and measurement in quantum mechanics are two different things. They are drastically different. In fact, as regards the classical information theory is concerned, uh, the whole theory is information theory is independent of measurement, because every time you are going to get the same result if it contains the same information and under the under classical information theory. But in quantum information processing, when you make a measurement, what you basically do is that you project the state into one of the eigenstate, or in other language, you project the state vector to some basis vectors that the measurement equipment defines. So here, measurement operator basically refers to the measurement equipment, you can say. To give you an example, let us say, I think I have given this example in the lecture class also. Suppose you have this superposition state. It's a a qubit is there. For example, it may be in the state k0 or k1. K0 and k1 are the basis state or the eigenstate. And when you make a measurement, you project the state into one of the qubit state, either k0 or k1. And now, in terms of physical system, this K0 may refer to the spin down state. For example, if I talk about a physical system, which is a, say, spin system. So in a spin system, this K0 may refer to, say, up spin, and K1 refers to the down spin. Or if I talk about a photonic system, because there we exploit the polarization state of the photon may be, it may be vertically polarized or it may be horizontally polarized. The vertically polarized one I can say to be K0, and the horizontally polarized one I can take it to be in as K1. So whenever a measurement is made, then either you will project you to the vertical polarization thing or polarized state, or you can make it to the horizontal polarization, or spin up state or spin down state. That is what the measurement means, and corresponding probabilities would be given by mod a square and mod b square respectively, right? These things by now should be clear to everyone. And this thing is actually done by formally, mathematically. This is represented by some measurement operators, and these things already I discussed. I don't want to repeat it again, but you see, the probability of getting an outcome is going to be given by this expression, and this measurement operators has to be Hermitian, and it has to satisfy certain properties, which also I discussed in the class. And the state immediately after the measurement is going to be this kate m, small kate m. And for example, if I talk about this particular example that I have just talked about, this arbitrary state is in a superposition of k0 and k1. And here you can define the measurement operators to be, these are projector, because if m0 is operated on this kate psi, you will find that this m0 operator is projecting this arbitrary state kate psi to one of the eigenstate, that would be k0, and m1 is the other projection operator that's going to project it to kate1. So if you are attending this live session, maybe you now see what measurement operators mean. And yes, indeed, they corresponds to some physical operations. For example, here K0 may refer to the vertical polarization state of a photon, and K1 may refer to the horizontal polarization state of the photon. Okay. So I hope I am able to answer your query here. Now, Guru Raja asked, basically he commented and something. So let me answer him. So I really thank you that you are. Hope you have found the course so far useful. You are asking, give some idea and instruction of exam related things. Kindly share some model problem for practicing exam. Okay, I will answer this. Then your third question was research doubt. Shall we stimulate this with Qiskit? Maybe you want to mean simulate. We are working on Qtron, QKD, QL. That means you are talking about quantum machine language, right? Okay. Yeah, you may exploit Qiskit to do a lot of basically qubit manipulation. It is an important tool, and you can, I think, a preliminary version is free to all of the people who are working in quantum information, or at least who are learning quantum information science. You can do some, manipulation and quantum circuits and all things you can do using QKit and other one. I will not comment on it much at the moment because but the things that I have taught in the course is definitely going to be helpful, because it is going to give you a perspective as well as some strong hold on the mathematical machinery of the things that's going on. So yes, surely you can do that. And you are writing in question in comment number 4, quantum entanglement lab preparation idea and what are the problems to simulation of quantum entanglement with IBM Qiskit. Uh, I think you can make quantum, definitely you can make quantum circuits, for example, a lot of C naught. You can use C naught gate. Maybe in one of the example in the lecture class or in the problem solving session, I have shown you how you can prepare Bell state using C naught gates, right? And those things you can definitely use to construct quantum circuits, and then you can write some, you can, prepare your own circuit to uh, have some quantum teleportation protocol, superdense coding, and so on. By the way, these are the topics that will come up in module 4. So hopefully then you will get the idea how this thing can be exploited. If you have used Qiskit and then you have done some kind of circuit, quantum circuit simulation or problem related to there using Qiskit, then you will actually get to do some quantum entanglement operation also there. At least you application of quantum entanglement you can see there using Qiskit. In comment number 5, you say, I saw your optomechanical research. They are interesting study to this. Okay. Yeah. Now, this is one of my goal was that you can understand this kind of research papers which I have worked on or other people. Now, in this regard, lecture 13 and 14 are going to be extremely useful, because there you will see uh, I have given you, actually, I have poured everything you needed to know to uh, decode a paper and understand a research paper. And I'm sure you will really get benefited after that. Uh, shall we use spintronics with quantum entanglement? Yes, of course, spin system, if I understand, if you're talking about spin system, yes, they are very much exploited for quantum entanglement study and all these things. You can definitely do that. Okay. Hope queries, if you are there, you can comment later on again. Now, yes, you asked this question, right? Some idea and instruction on exam related things. The exam is going to be very simple. Let me make it very clear. You have nothing to worry regarding the exam. Why? If you have done the assignment, uh, the questions are going to be based on the assignment kind of problems, similar kind of problems we are going to ask you. Recall based question would be there, for example, related to density matrix and properties and all these things. Simple questions. These are definition or information based questions would be there. Recall based question would be, I think, 10 marks. Assignment would be some 20 marks, or I forgot it, something like that, or 25. And open question would be some 20. So 20, 20, 10, like that kind of. Open question also, there's simple questions based on whatever I taught you in the problem solving session. In open question, only thing you have to do some calculations and to do the paper. And to be honest, you can actually complete the paper by maximum, 2.5 hour. But if you are really good, and you can complete it within 2 hours also, if you are very quick if you do the things. So it will not take more than 2.5 hours. So half an hour is given as a bonus. You can actually uh, you need not have to worry at all about the examination. My purpose was in this course was only to give you some, understanding about quantum entanglement, and hopefully you learn at least something there. Okay, so hope it this helps you. Now, Manviz asks that will there be an internship opportunity after the completion of this course? Yes, if you have done this course, if you are interested, definitely you can write to me after completing this course. Then, after completion of this course, if I want to further study about quantum entanglement, what courses or book will you recommend? These are actually little bit this whole thing is a research level kind of a, but not that much accessible. There are chapters on quantum entanglement here or there, not even chapters in some sections are there here and there in many quantum mechanics book or quantum optics book and so on, but there is not a full-fledged book. For example, in this book, famous book by Nielsen and Swan, here you will get to know about a lot of things about quantum entanglement, but there is not a dedicated book as per se on quantum entanglement. And there is, by the way, very, you remember that Horodoki, I think if I have talked about that or if you have already got it, maybe you will encounter Horodoki, Paris Horodoki criterion but that is not that Horodoki. I just see this Horodoki family kind of, they have written a extremely nice review article on quantum entanglement. Maybe you will able to get a free copy of this review article in Google also. If you search it, it should be there somewhere. Uh, you can look at it. And then there is a, as regards entanglement measure is concerned, you can look at this article. This is freely available. You just Google it, or you can just note down this archive number, or you just note it. This would be good enough. An introduction to entanglement measures, if you just type it in Google, then you will be able to get this article. Uh, you will get some idea. Again, these articles are written in a little bit inaccessible way for beginners, but after if you have done my course, if you are doing it properly, then you'll be able to understand this particular paper as well. Okay, so I hope it helps. Yeah, I think that's it from my side. As regards your queries, which you have asked earlier. Now let me. Now you can ask me questions. Now I am ready to take up other questions if you have any. Let me see the. Or you can ask. You can just unmute yourself and you may ask questions. Couple of questions. I love to take, and any comment actually. As I can see, Guru Raja is there. Yes, Guru Raja, are you okay with my answers? Can you speak up, please? Can you hear me, Guru Raja?
Yes, sir.
Yeah, so have I answered your queries?
Yes, sir. All the query I got answered, sir.
Oh.
Sir, if we use C not gate, we not get the random numbers, sir. If we use C not gate, true randomness is not getting, sir.
No, C not gate is it's a basically a 2-qubit gate, right? Its purpose is not to create
Yes.
random numbers. Maybe you can. It may be useful with some other circuits, and then maybe you can develop a quantum circuit where C not gate may be one of the component, and you may construct a random number generator kind of thing. You may think about that.
Yes, sir.
Yeah.
Sir, if we go for entanglement, what is the uses for the QKD, sir? QKD protocols. Major thing is there in QKD protocols, entanglement based
Yeah.
protocols.
Exactly. Entanglement is used as a resource. I think if you do module 4, there you will get some answers there. You will see how
Yes.
entanglement is exploited for quantum teleportation, superdense coding, and even I have given you an example there about how entanglement can be exploited for quantum sensing. Okay, so I have just briefly talked about that also, and quantum QKD also, protocol QKD protocol also exploit quantum entanglement. So I think
Yes,
after
sir.
you do the module 4, you will have good idea.
Yes, sir. What is the basic idea of these problems or getting in books, sir? Which book we have to follow for all mathematical related derivations, sir, of
But
entanglement?
if you have gone through the problem solving session, then these are typical quantum mechanics kind of a problem only, right? If you just now, if you look at it from that point of view, and if you are asking that you want some source from where you can solve some problems, then as I have said that I cannot recommend you any book focused on quantum entanglement, but overall the topics that I have discussed that are in many books. For example, you can pick up any quantum optics book such as Introductory Quantum Optics by Gary and Knight. There is some chapter on quantum, some portion is there dedicated to quantum entanglement. Then even density matrix is also there in many textbook. You can do some problem related to density matrix and so on. And you may actually, if you want to practice some problem, then you can look at Nielsen book is there. It also contains a lot of exercises. You can try that book also.
Okay, sir.
Yeah.
Sir, in LLGS equation, PT symmetry is also already you are working, sir, and then that your research paper also mentioned that PT symmetric PT symmetric related things you are worked at, but LLGS
Yeah.
equation we can simulate this
Yeah, Guru
in.
Raja, you see, Guru Raja, I don't want
Yes,
to
sir.
talk about that because that would be, you may write a separate email to me for that because
Yes, sir. Sorry.
this
Now,
would be different topic altogether, so it would not be good for
yes, sir.
others. Yeah, so you
Uh,
can, I will try to answer
understood.
it there. Yeah.
Okay, sir. Okay.
Yes. Others, please. Others are completely. For example, Prabhat is there. Prabhat Ranjan. Then you can ask me questions, or you can comment also. You can also say whether you have liked the course, or you may also say, ki, okay, there are a lot of expectation was there. I was unable to fulfill it. You can say all those things, no problem. Uh, Anything? Then
Namaste, sir. I am Prabhat, sir, from Banaras
yeah, Prabhat.
University, sir. Sir,
Yeah,
actually,
Prabhat. Yeah.
sir, I want to work on philosophy of physics, sir, especially quantum physics. That
Okay.
sir, many philosophers and physicists are working on that on quantum physics, sir, like Tim Walden, Carlo Rovelli. Sir, for research purpose, actually, I am not a student of science, but I am a student of philosophy. So, sir, I have problem with mathematics, sir.
Oh,
And
yeah.
have, sir,
You see, Prabhat, I made it very clear at the beginning of the course. Of course, even when I launched this course, there also, I think, if I remember, I said that this course we are going to avoid philosophy. Uh,
yeah,
because the reason is that there are too many literatures are there, a lot of things are there as regard philosophy is concerned. People are fantasizing about teleportation, this and that. But ultimately, what I believe is that philosophy may have its own, importance. But as a physicist, as a physics, researcher, uh, I think I am more interested in applying it for some useful purposes rather than philosophizing over things, and that's why the purpose was to teach you some mathematical machinery, so that ultimately you can understand research paper and apply that, or even some of you are really one, you can even join the research, or you can plan to your career like that. Okay, I will do some research related to quantum entanglement, because quantum entanglement has become an extremely interdisciplinary kind of a research area, so it's very much required. So mathematics is a must. So Prabhat, in that case, the purpose was not to discuss philosophy at all. But if you want, then there are some lighter books are there on entanglement, quantum entanglement, who that discusses a lot of philosophy on this right now.
Yes, sir. I have bought, sir, from Princeton University. That is written by Tim Walden, sir. Introduction to Quantum Physics. He has written on many topics, and I am reading, sir. And
right.
Yeah, I'm also, sir, reading some books on mathematics, sir, and practicing. I have joined some course on calculus, linear algebra from IIT
Okay. Right.
So
Then eventually, Prabhat, you will be able to understand this course also if you have completed some preliminary study on some, because the level of mathematics that is required is not very, uh, I would say, advanced. If you have a good knowledge about vector algebra, linear, what is this called? Linear algebra, that should be good enough. Okay. So I think good luck to you. You'll be eventually
sir, last question, sir. As you have mentioned that we can write to you for internship, sir. Sir, can I also write, sir, for internship?
You may write to me, then I will consider. I will think about that because I have to first see.
Yes, sir. Yes, sir. If I completed course, sir, then.
Of course. Please, later on you can write to me. Okay.
Yeah. Thank you, sir. Thank you.
All right. Okay. So.
Good evening, sir. This is Lakshmindra Mohanty here.
Oh yeah. How are you?
Yeah, I'm doing good. Thank you, sir. Hope you are doing good. So I'm working in industry, but I do not to take that name of the company here. I can write you one-on-one. In quantum area, I'm there with the last 2 years. I've done a couple of courses from IIT Madras, and I'm using Qiskit and CSAP, QSAP in my program. So mostly I have done a couple of projects, but because of the hardware constraints, it's like we are not able to implement in the real client applications. But a lot of focus is coming in quantum entanglement with respect to QKD and QRNG. Those areas is coming. I'm working in that particular field. But here, whenever we are implementing the applications, I'm facing one difficulty is like to convert this mathematical equations to quantum things. So that's giving me a lot of troubles. But if you, it's not like how we are writing general programs like C++ or BC++ or Python. This is not simple program. Just you can go ahead and implement, because all the like predefined libraries are available in all other programming languages. But for this quantum field is very new. But yeah, I've done a couple of mathematical implementation, but it's a really interesting field. And I can tell I'm not referring only one book. There is a lot of books that they are here and they are beaten pieces like to follow that one. And one more, the most interesting field I I my research area is like quantum sensing, which is like we have done one experiment in BMW. I can tell that client name. And for the quantum sensing, the positioning, sensors in the proper place, which will give you more focal length as well as more visibility, or sensing the objects very fast and give the outcome, desired outcome in very early stage of before occurring any event. So this is a really interesting field I felt, and sir, I can say you thanks to you because of this course, because I learned a lot, because I know entanglement, but mathematically I never tried that, because
Thank
we
you.
are
Thanks a lot, Monty. I think you will really, really like my lecture 13 and 14 because at least that's what I got some feedback from my research students. They found it very useful because those things are not available anywhere, and I have decodified that. So hopefully you can look at it, and then it will definitely help you research at least where Gaussian states are involved. I have explained everything there. So thanks a lot for your comment. Now let me open the chat box here, and I see some questions. Let me take some quick questions there. Uh, 1 minute. So let me, Guru Raza, I have already answered your this. Bathri is a MSc student. Okay, thanks for your comment. You are you are asking. I had done a project on quantum Carnot engines and would like to switch to QKD. What books would I refer to the for the same? For QKD, I think you can. There are one is Nielsen book is there. You will get something, but there are other books. There are books by one good book is there that is author is I think Nakamura, Quantum Computing. I think you can pick up any book on. There are so many books on quantum computation, and every book on quantum computation is almost every book is going to discuss about QKD protocol. So please pick up that book. I think any quantum computing book, particularly, but you go for some those books whose are published by good publishers. For example, Cambridge University Press books are really good. You can pick up those kind of books. I think that will help you. So then, yeah, another question by Shruti. My question is, can quantum computing can be coupled with density functional theory-based calculation ab initio in any way, or can this be related? At the moment, I am not aware about that if some people have done coupled density functional theory, but my guess is that yes, it may be required later on because at the moment what is happening is that people are ultimately you have to play with lot of complex system, lot many qubits you have to deal with, and when your system becomes quite complicated, kind of many body kind of stuff, maybe I was disconnected in between. So I was answering Shruti's question. Her question is that can quantum computing be coupled with density functional theory based calculations? I'm not aware of any work so far, but perhaps it may be uh, useful later on. At the moment, I have no idea, but it seems that those things would also become very useful. Then Mustafa is asking, is any questions? So thanks for your comment. You are okay. Thank you so much for your nice comment. And then uh, ZB Raghav Krishna, you are asking if, for example, I want to measure energy in the state, then are we allowed to use Hamiltonian operator in the place of measurement operator in the given equation? Okay, it's related to measurement. Okay, Uh, Actually, measurement operator has a particular purpose. These are always designed in such a way depending on the experiment. Right. For example, the example that I have given in the beginning, it depends on what you want to measure. For example, if you want to measure whether the spin is in the up state or the down state, then accordingly you do that. Now, if you are talking about energy, uh, maybe yes, but Hamiltonian, I'm not sure whether it's not a projective kind of an operator, right? Uh, it should be projector. So I'm not, I think you can design it that way, right? You can design this thing, but directly whether Hamiltonian you can use it, I don't think so. You can use it because measurement operators, if you have done that particular lecture, you see it has to satisfy certain conditions. If you remember, suppose you have two measurement operators are there corresponding to one measurement, then the property it has to satisfy is a total projection should be equal to 1, right? M0 dagger, M0 plus M1 dagger, M1 should be equal to 1. That those properties has to be satisfied. Then it would be qualified to be this thing. So please think about it. I think that's what that answer, that's the way I look at it. Then you are writing other than assignment problems and problems for problems, are there any other material that we can use for practicing for exam? For exam wise, as I have already assured you, if you have done the materials properly, assignments and the problem solving, you are through. No problem at all. I can that much I can tell you, because moreover, there is no negative marking. So you can attempt it and you will get ample amount of time. So but if you want to practice something, I would rather say for density matrices kind of thing, because density matrix are at they're the backbone of a lot of things in quantum computation and entanglement kind of business. Try to solve as much problem as much possible for related to density matrix. This will really help you. And for that, you can get lot of materials from internet also, because in many universities, if you just write down density matrix tutorial or this and that, many problems that you will be able to discover, and I think hopefully that would be a good starting point for your exercise. As regard density matrix specific is concerned, any quantum optics book, if you pick up, then there is always a discussion on density matrix first, because they are so essential mathematical tools. Okay. Right. So yes, you were saying Nakahara. Yeah, I'm talking about Nakahara's book. Nakahara's is a very good book is there that is called Quantum Computing. That book is very good. Somebody has. Oh yeah, yes. There is a book by the problems and solutions in quantum computing and quantum. Yes, that also you can look at it. Yes, that book also you can look at it. There are a lot of problems are there. That also you can look it. You can look for problem solving purposes. All right, Shruti, thanks a lot for your nice comments. So I think, yeah, we are good. Any more queries? I have not seen anything in the here YouTube. Okay, I think people are able to put questions in the chat box. That's good enough. Yeah, NPTEL team, is there any queries there in the YouTube this thing? Can you tell me, because I'm unable to look at it. Okay. So I think we are good. We have covered a lot of queries from, and I thank all the participants for attending this live session, and please do the course, rest of the course, wish you all the best, and I'm sure you will do good, and you will keep on studying about quantum entanglement. And please drop me email after you complete the course, any internship and all these things. If I can help, if I can take you as an intern, I will definitely do that. Okay.
Thank you very much, sir.
Okay, Mohanty, thank you.
Thank you very much, sir.
Okay, thanks. It's pleasure for me to answer your queries. Okay, then I think should we leave now then? And people, yeah, yes. Oh, okay. Thank you so much then. Thank you.
Thanks, everyone.
Okay, bye bye.